When you hear the bloop, that means it's starting to record. There we go. All right, so our fourth lesson is doing inverse trig functions. And you did these a little bit in geometry, but they weren't really talked about a whole bunch. It was just like, if you're trying to find an angle in a triangle, you're going to use this -1 thing. This is our trig functions and angles number 4. It's inverse functions. So we use an inverse function if we know the ratio, we know the opposite over hypotenuse, or we know the adjacent over hypotenuse, we know those two numbers. We just don't know what the angle is that goes with it if you're doing sine of that or cosine of that. So you're trying to figure out what the specific angle is. So that's when we use our inverse trig functions. So we use the inverse to find an angle. There are two different ways that people represent an inverse trig function. The first way is the one that you're probably most familiar with. The inverse of sine is when you have sine with a little -1. That is above your sine button in your calculator. If you hit second sine, that is there. People also say arc sine. These two mean the same thing. I'll use them interchangeably. Just know that this is both the inverse of sine. So inverse of sine or arc sine mean that we are trying to find the angle. They're giving us the opposite over hypotenuse part. We want to find the angle. Same thing with the other ones, inverse cosine or arc cosine, inverse tangent or arctan. We're going to do some ones that are in triangles and like practical problems first, where we're solving problems and using our calculator. And then we'll do the ones where we have to use the exact values using our special right triangles. Okay, so we'll start out with our practical problems. That's as if we're solving a whole triangle. Or if they just want you to find one specific angle, you can do that as well. So we want to find all of the sides and we want to find all of the angles. Go ahead and fill out everything that you already know that they gave to us. So we know C is 90 degrees. Little c is 9. Little b is 6. Before we use our arc sine or tangent or cosine, whatever we're going to use, let's go ahead and find side A. To find side A, we're just going to use the Pythagorean theorem, right? A, we don't know. These are both of our sides, and then we have our hypotenuse. So A squared plus 6 squared is equal to 9 squared. 81
minus 36.
Yeah, 81 minus 36. I should do that in my head, but I didn't. It's 45. We take the square root of 45. Isn't 9 in there? Yeah, 9 and 5. So that's 3 root 5. Okay. All right, so now we have to figure out what our other two angles are, and we don't have like one we can subtract from 180 or anything. So what I'm going to do is I'm going to pick one to start with. Do you want to do A or B first?
B.
B, let's do B. Okay, so I'm going to say I'm looking at, I want to find B. This is just like we did last time. I know these two sides. Angle I want, sides I know. And then we're going to write out what this would be, how they are related to angle B. This is the opposite, and this is the hypotenuse, right? So opposite and hypotenuse tell us we're going to use, just mouth it, sine, right? Okay, so sine of B is equal to opposite over, not in I can actually write the numbers, 6 over 9. And we don't know what B is. So for us to do that, we are going to do the inverse sine of 6 over 9, and that will give us the B. So inverse sine of 6 over 9 is going to give us the B that we want, the angle. So make sure you're in degrees in your calculator because it's a triangle. Hit second sine for inverse. Do 6 divided by 9. And did everybody get 41.8 degrees? When you type that in?
I did.
Good. You didn't or you did?
I did.
Okay,
but I put it in degrees.
Yeah, it needs to be in degrees.
So when I put it in degrees, I don't think it says, like, how do I get off of it with it? So it's like,
You got mode.
Yeah. Mode and then degrees. Once you click it in degree mode on your calculator, it stays that way until you switch it. So you don't have to check it every time for those.
So do I just answer and then click clear, or?
No, the calculator has two different modes. It can answer all your questions with the answers being in radians, or it answers all your questions with them being in degrees. So you have it set to give you your answers in degrees. So that's what it's going to answer you in. So you don't have to do anything once you type the inverse sine of 6 over 9. So 41.8. Okay, and now we can switch over to A and then see what that's going to be, cosine whatever. Or once you have two angles, what do you need to do to find your remaining angle? We just subtract them from 180, or these two are always going to add up to 90 because the other one was 90. So I'm just going to subtract 90 minus what I just got. So the other one is 48.2. Okay. So 180 minus 90 minus 41.8 is going to give us our third angle. Do you guys remember doing the inverse sine, cosine, tangent stuff in geometry? Yeah. Whenever you're finding an angle, you look at the two sides that you have. How are they related? Is it sine, cosine, tangent? And then you use that trig ratio. Okay. The first questions you have in your homework just tell you to find a specific angle. You don't have to find everything. So just go to that angle. What are the two sides that I'm given? Let me use those and do the inverse trig ratio. All right, now we're going to look at how to figure it out if they give us an exact value. So our answers are going to be what we would have if we used our special right triangles. So there'll be a 1/2, or there'll be √3/2, or √3, or √3/3, and we have to know what angle measure would give us that. Okay, so we're going to see first, this is an important part of our inverse functions with this, is that if you're going around the circle from 0 to 360, sine of 30 degrees is equal to 1/2, right? So sine is 1/2 at 30 degrees, but it's also 1/2 at somewhere else on there because there's another place where sine is positive and they match up. So around your circle, sine is 1/2 2 times. Cosine is 1/2 2 times. Cosine is a -1/2 2 times, but we only want to find one answer. So we limit our circle so that we don't get two answers and we don't get confused. Okay, so for sine, cosine, and tangent, we are limiting where we look or what our degree measurements can be for our trig functions. Okay, so these are our limitations so that we know specifically what's going to be the answer. They're just going to give us half of the circle. So for sine, if the sign they give you is positive, you are going to look in the first quadrant. Okay, so if they're saying inverse sine and it is positive, you're looking for your answer in the first quadrant. We could also have something negative. Where is a quadrant where sine is negative? Quadrant 3, it's negative in quadrant 3, and then what other quadrant is sine negative? 4, okay. We're looking in quadrant 4 for our negative answers. So we are limited to quadrants 1 and quadrants 4 when they're asking about inverse sine. We do not look in quadrants 2 or quadrants 3. So these are off limits for sine. We're going not here and not here.
Why wouldn't it be across?
The way that it works, and it's going to work when we see the graph of it later on, they want to have it where there are two things that are right next to each other. They don't want to have it like this and then a space where it's not and then a space where it is. So they just have it, these two are connected, and so they want them right next to each other.
Okay, thank you.
So they want a positive and negative that's connected. All right, now cosine. Cosine, if we're positive, we're going to look in the first quadrant. When is cosine negative? What quadrants? 2 and 3. So which one do you think we're going to use? We're going to use 2 because that's the one that is connected. These are the ones that are right next to each other. So we're going to no-go here, no-go here. So if they're asking you about cosine, you're only looking in quadrants 1 and 2. 1 for positive and 2 for negatives. In tangent, we do the same thing as sine, even though it's negative in both of those. So I guess someone just decided we're just going to be limited to 1 and 4 for tangent.
Is this for like only inverse?
Yeah, only for inverse.
Okay.
So the angles you're looking for are going to come from the quadrants where we have the plus or the minus. That'll be all. So we're going to write our answers in both radians and degrees, just so you'll know either way. Okay, so we have sine, inverse sine of a half, inverse sine of root 2 over 2, inverse sine of negative root 3 over 2, inverse cosine of root 3 over 2, inverse cosine of root 2 over 2, inverse cosine of negative root 2 over 2, inverse tangent of 1, inverse tangent of negative root 3. All right, so we need to know our stuff from our triangles. So have that out. Then we also think about our quadrants as well. Okay. Y'all got that written down almost? And we have our triangles next to us so we can look at it. So someone help me out. Inverse sine of 1/2, they're asking. So it's in the first quadrant. So we know it's between 0 and 90. When is sine a half? What angle measure gives us sine that is a half? So look on your triangles from section 2.
60.
When is sine a half? You're close. Is it 30, 60, or 45?
Would it be 60 divided by 2?
It's 30 degrees, right? So sine of 30 is 1/2. Everybody see that on their triangles? Sine of 30 is 1/2. Okay. So inverse sine of 1/2 is going to be 30 degrees. They're asking you for which angle is sine a half. So 30 degrees, and that in radians is pi over 6. Okay, y'all look at the next one. Inverse sine of root 2 over 2. For which degree measure is sine root 2 over 2?
45.
45, good. 45 degrees is our answer. Or in radians, that is pi over 4. All right, so our next one is inverse sine of negative root 3 over 2. So we know our answer is going to be in the second or fourth quadrant, right? It's going to be in the fourth quadrant. But the reference angle we're using is coming from this. So when is sine root 3 over 2? When it is 60 degrees. So we are 60 degrees under the x-axis here. So 60 degrees under the x-axis. So the way that we write that, we don't have to subtract from 360. They let us just go like this, negative 60 degrees, because it's 60 degrees under the x-axis. From our reference angle, negative 60. Or negative pi over 3. So when you are in quadrant 4, we don't have to say what it is between 270 and 360. They let us just say whatever it would be if we subtracted that, if we went down that much. Just makes it a little bit easier for you. Okay. All right, let's look at the cosine. I want you to try the first two on your own. Just write what the angle measure would be if cosine was root 3 over 2. And if cosine was root 2 over 2, what are those angle measures? So look at your triangles. All right, and cosine is root 3 over 2 at which angle measure?
30.
30 degrees, which is the same thing as pi over 6. Cosine is root 2 over 2 at
45.
45. That's the same as pi over 4. And our other one, we are in the second quadrant, not the fourth. So second quadrant, we just do regular numbers. So negative root 2 over 2. Root 2 over 2 for cosine is 45, right?
Yeah.
So our reference angle would be 45 degrees. So it's kind of like going backwards from yesterday. They tell you that, then you're like, okay, that would be the reference angle. So what is the full angle measure here?
135.
135, and that's going to be our answer. 135 degrees. 135 degrees, if you switch that into radians, 135 is how many pi over 4s? It is 3 pi over 4s. Pi over 4 is 45 degrees. There's 1, there's 2, there's 3. You can also switch it to radians like you know how to with your conversion factor as well. If you do your answer in degrees and the answer they have as an option is in radians, just make sure you switch it. Okay. All right, now tangent. Tangent is 1 for which angle measure?
45.
45 degrees or pi over 4. And tangent is root 3. Tangent is root 3 at 60 degrees. But since we're down here, they say you can just write that you're going backwards 60 degrees, so negative 60. So if you're in the fourth quadrant, just do negative of whatever your reference angle is. Okay. If you do not have all of these triangles written down that we are referencing to get these answers, that is from Unit 2. You'll need to watch that video and stop after the special right triangles to write all of these down so that you'll have them and you can use them. Okay, if you're like, I don't know where any of this stuff is coming from, make sure you go back and watch that second lesson. So they're giving you like what would have been our answer before, you go back and find the angle. Thumbs up if that's okay. You're just looking and writing the angle down? Okay. If it's negative on sine and tangent, just write negative of whatever that angle is. On cosine, you have to make a little reference angle and figure out what it would be. All right.